Hello viewers, welcome to this video lecture series on C programming. Here I am going to give some examples, that is few programs wherein you are using variables by declaring it as short integer data type. So let us see the very first one, the example one. This is a simple, you need to print the value on the output screen and the value for the variable you are assigning it in the program only. So here we'll check. The first thing is, in this particular program you are using what? Signed short int num equal to 20. So with this declaration statement, it will select a memory location randomly and the name of the memory location will be num and it will have some address. Okay, this particular location in the memory, the address, let me take simply randomly 2000. This is the address in the memory. So presently we are not going to worry about the address, just I am writing here address in the memory. Now the value what you have assigned here is 20. So that means in the program you are saying the variable num is equal to 20. So what exactly will happen is, because this is a signed short int is what? It will accept both positive and negative values, and you are giving a positive value, it is a valid value here. And moreover, in the signed short int scale, so normally we'll call it for our convenience the signed short int scale as %d scale and the unsigned short int scale as %u scale. So let us remember like this. This is the %d scale and %u scale. On this scale only we are writing the range for this particular data type. The positive values will start from 0 to 32767, okay, and the negative values will start from -1 -2 to 32768. So you have given a value 20, which is definitely what present in this scale. That means you have given a value which is there in the range of this particular %d scale. So the output will be printed here. The output is simply what? Whatever number is assigned here, that means the 20 value. So this printf statement, when you see here, the compiler, when it reads this printf statement, you are specifying the %d as the format specifier. So %d scale has got a value 20 here, okay, and it will fetch, it will take this value from this memory and then it will print here. Fine. So output is 10 in this case. Very simple. Like this, if you are giving any value num equal to 50, no problem, it is there in the scale, it will get printed. You are writing what? %d, definitely it is an integer type. Then if you are giving any negative value, that too which falls within this range, only then it will get printed and you are going to get the output. So now we need to check what happens if we are giving a value which falls beyond this range, which is not at all there in this range. Like we'll try to give some examples here. In one example, I'll try to give a positive value which is not there in the range. I'll try to give a negative value which is not there in the range. Then we'll see what will be the output on the screen. So let us go for the second example, that is the program 2 here. The declaration part is signed short int. Here also I have taken the data type as short. Definitely data type is short, but I have taken it as signed one. Previous also I had taken signed. So signed is what? It can accept both positive and negative numbers. Look at the value that I have assigned to this variable. What is that I have assigned? Num equal to 32769. This is a positive one. But if you see the scale, look here, the scale is what? The highest value which you can give it to a variable is 32767. But what you have done is 32769. It will never look into this value that is assigned into the statement. Rather it will start counting on the scale this particular count. That means it will, I'll show you with an example. See, the declaration is signed, so we'll refer the signed, that is the %d scale. In the %d scale, these are the values. Now maximum positive value you could have given is 32767, but what you have given is 32769. Fine. So how it will work here? It will count up till here, fine, 32767. Then whatever is the next number, fine, whatever is the next number, it will take it as 32768, irrespective of the sign. Just imagine if you are joining, okay, this end of the scale, fine. If you are joining this end of the scale with this, and the next number that comes here is what? 32768. And look here, suppose if this negative numbers were given, the just previous number for this will be 32767. Fine, and just previous will be 32766. So these are the numbers already there on the scale, on the %d scale. But since you have assigned a value 32769, it will count up till here 32767. Fine. Then next it will take this as 32768, and this number it will take it as 32769. Look here. This is what now 32769 is becoming what equivalent to minus 32767. And in the output, that means whatever is the memory location that is allotted to num, the value that gets stored is will be minus 32767. Fine. So here it will be minus 32767. Now look at the difference. There is no relation at all. Whatever input you have given and whatever number it is getting stored here in the memory location. You had given a positive number 32769, but it is storing what? Minus 32767. Hope you people have understood on what basis minus 32767 is stored. The next statement is what? Printf. Before printing, once again, because you have specified the format specifier as %d, it will check whether 327 minus 32767 is present in the scale or not. Yes, it is present in the scale, and therefore the output is what? Minus 32767. So it is simply not printing directly here. First it will check whether this number is present in this %d scale or not. Fine. You can call it as a scale or join both the ends and make it a circle also, and you can say %d circle. So that is also fine. The next example will take example 3. It is used to print a value. Once again it is used to print. So all the programs are used to print a value on the output screen only. But here we wanted to check what value gets printed, what value you give and what value gets printed in the output. So in the example 3, what I have done is, now I have declared unsigned short int. Okay. Unsigned is what? It will accept only positive values. Fine. And what is the scale called as? We are calling it as %u scale. And the very beginning only I had told you a very simple scale. It starts from 0, okay, 1, 2, and it ends at 65,535. This is the minimum value and this is the maximum value. But look here, I have given the value as a equal to 65,539. But what is maximum value? 65,535. Intentionally I want to print here 2 times the output, one with a format specifier %u, that is the unsigned short int format specifier, and one with %d, that is the signed short int percentage specifier. So this is the scale, okay, 0 to 65,535. So we normally call it for our convenience as what? %u scale. Fine, you have declared it as unsigned short int, so it is %u scale. With this declaration, definitely a memory location gets allocated, and the name of the memory location also will get assigned. Here you have given the variable name as a, so it is a here. But what value goes inside to this memory location is it will check this %u scale. That means it will simply count the numbers. Look here, if this is 65,535, when you join this end, so it will try to see what is the next number after this. How to get the next number? Simply join the other end. Fine. Or you can make it as a circle also if you want, like this. Fine. So that means you started from 0, 1, 2, 3, 4, like this. The last number is 65,535. Now when it starts counting, it will take 65,535. This number, which is 0, becomes what? 65,536. This 1 becomes 65,537. This 2 becomes 65,538. And this 3 becomes 65,539. That means you just see here, the number which you have assigned to the variable is 65,539, and the corresponding value on the scale is what? 3. So the output here in this memory location, actually the value in this memory location will be 3. So in the output also it will get printed accordingly. According to what? According to the %u and %d specifier. But before printing, now the value is there. It is decided that the value is 3 here. But before printing, what it will do is, it will check. The first printf statement says %u. %u, well, it will check whether this value 3 is there in the scale. Yes, it is there. Yes, it is there. Okay, in both the formats. Yes, it is there. So it will print. Okay, fine. The output is 3 in this case for the first printf statement. Similarly, next printf statement, you are trying to print percentage %d. You are using format specifier percentage %d. Percentage %d is what? Percentage %d scale. It will simply check whether 3 is there. Yes, 3 is there here. Then the output for the next printf statement will also be what? 3. Now what is that you are observing? You have given an input as 65,539, but it is getting printed as 3. Where we try to break the rules, C language will not provide any compile time errors. If you are violating also, it will not provide any compile time errors. Instead, it will give you some unexpected results. Most of the time in the interview questions, rather than asking the direct questions, they may ask like this, what is the logic behind it? So this is what you have to understand here. Now we'll see 2 more examples here. So in this example, this will be the example 4. So we want to print a value on the output screen, but what is that we have assigned? We have assigned a equal to -5, but declaration is unsigned short int. So unsigned short int, if you want to take unsigned short int a, unsigned short int scale, if you want to see, unsigned is it is going to accept only the positive values. I have drawn the scale 0, 1, 2, it will accept up till 65,535. The same scale, if I join both the ends of the scale, then I can represent the same thing in a circle form also. This one I have done it here, the circle form. So in the circle form also you can see the minimum value is 0, 0, 1, 2, 3, 4 and maximum is 65,535. But the value that is assigned in the program is a equal to -5. So with the declaration, the memory allocation is selected. The memory allocation will get a name as A and it is having some address randomly. Let me take 2024. Now first it will see because you have given a value which is not in the range for unsigned. Unsigned is always from 0 to 65,535. You have given a negative value, but still what exactly happens is immediately whatever number is present here is 0. Fine. After 0, this number becomes -1, this becomes -2, this becomes -3, this is -4 and this is -5. The value assigned is -5. Now for this -5, what is the equivalent number? 65,531. So 65,531 value is stored here in the memory location. Now the printf statement, printf %u, the format specifier is %u. Before printing this value, it will check whether this 65531 is present in the scale or not. Yes, it is present in the scale. So it will fetch the value and the output is what? Output is 65,531. Now look here, there is no relation at all between the input and output. You had given a value a equal to -5 and you got an output as 65,531. So let us see one more example. This will be the last example. In this example, we have declared the data type as unsigned. That means unsigned is what? It is going to accept only the positive values. But what value you have given is a negative value, -32773. So if it is an unsigned, let us see the unsigned scale. So let me just correct. This is %u. This is the unsigned scale and this is the signed. Here the value assigned is 32773. A memory location will be allocated and the value and the name for this memory location is A. And since it is an unsigned short, it will check the %u circle and in the %u circle you can see all positive numbers. The same previous program logic gets applied here. You have given a negative value here, so that is why, and always the counting starts from 0. It will start counting in this %u circle only from 0 and the next number becomes -1. 65,535 becomes -1, 65,534 becomes -2, like this. This is -3, -4, -5 till where you need to count till you reach this number -32773. This is your negative number. That means the counting starts from 0 and the very first number is -1 and you have to reach up till 32773 and see what is the corresponding positive number on the scale. Now to find out from this circle, it is difficult. We can take the help of %d circle here because both the circles anyhow got the same amount of numbers. Here also you have 65,536 numbers. Here also you have 65,536 numbers. So we can take the help of %d circle in this case. Just see the positive numbers only here. So we'll see that 1, 2, 3, 4, 5, 6, 7. So it is taking up to 32768. So we are seeing the corresponding what? Positive number. This is 32768. This becomes 32769. Fine. Okay. This is 327. 70. Which one? 66. Then this is 32771, 65. Then 32772 is your 32764. Finally 32773. 32773 is your 32763. So now we got finally the equivalent number for 32773, which was assigned as a value to this variable. So value that gets stored here is 32763. Look here, the number given was minus 32773 and the value that is getting stored is 32763. So this is the output. Compiler will never directly print this. It will check in the printf statement the format specifier %d. %d is the signed circle. It will just see whether 32763 is there. Yes, it is there, 32763. Then the next printf statement is %u. %u is the unsigned circle and it will check whether 32763 is there. Yes, it is there in that circle also. So this output is what here? 32763. Even here the output is what? 32763. So remember here, the declaration, whatever declaration value is given, it will not consider that value, because you are violating the rules, you are not following the rules. It will always check the signed scale or the unsigned scale, or you can say signed circle or the unsigned circle. Whatever is mentioned in the declaration, whether it is a signed value or unsigned value, so the corresponding scale or the corresponding circle is checked and the new value gets stored. Wherever the rules are not followed, there is no relation between input and output. That hope you people agree. So there is no relation. We got a different number in the output. We had given some number, we got a different number in the output. So the conclusion is what? It will not give any compile time errors also. It will give some unexpected results. And so normally when students are typing such programs and trying to give a values which does not fall in the range, they get some output, unexpected result. But the logic is this one, whatever I have explained in this session. Hope this session is useful to you all. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.